All right, so let's jump into what we're here to talk about. So, first thing, let's take a look at the important nodes that you need to know about that are relevant to today's lesson. So, we need to talk about materials and shaders and texture maps and things like that. So, how does that all play into what you do in Katana to achieve your look development? Now, there are two uh, basic types of material nodes. There's the material node itself and the network material. So, what's the difference between the two? The material node will allow you to create a shader, and then it will exist in your scene from that point forward, and it is a basic assignment in that you have access to the parameters that are set up in the shader. There's a kind of a hidden part that we'll talk about in a minute, or just an extra layer, shall we say? Not that it's really hidden. It's a layer of opportunity within the material node. Now, the network material is what you would use if you want to connect various nodes together. So, if you want to have a fractal that is feeding into a texture map that is feeding into something else, so on and so forth, like you would normally do in most shading network authoring tools, the network material node is your starting point for that. So please don't go into a material node, being this one, and think that you are going to make those connections, because you'll then sort of bang your head against the wall and find yourself, you know, getting frustrated. The layer that I do want to talk about later is that you can create a network material. So a full network of fractals, file textures, whatever it is you want. And you can package that up like a gizmo or a macro, HDA, Maya asset, whatever sort of analogy works for you. You can package that up and create what looks like a monolithic shader and access it through a material node. So we'll cover that in a bit. Power being there that you've got the flexibility to do both. So there's a recurring theme in Katana, power and flexibility, all of it driven by pipeline needs. Okay, so material assign node is the next one that we'll need to make sure we cover. The material assign node is the fundamental node for basically attaching the attribute. And again, like we were talking about in the last video, there's parameters and attributes. So everything in Katana, you are using parameters, being the controls, to assign attributes to scene graph locations or operations that create and alter those scene graph locations, right? So that is the reason why you have the material assign node. So its simple job is to say, hey, here's something in my 3D scene, and this is what I want you to list as its material attribute. So the assignment. All right. Every render plugin has a shading node. The difference just being that you're going to have PRMan, you're going to have DL, Arnold, V-Ray, Redshift in front of it, but consistently you always have the shading node. This one is what helps you create that network of materials. A big part of things is the look file. The look file is our way of connecting things together, and we'll talk a bit more about that later on. By connecting things together, what I mean is it is the glue that binds the work you do in look development, or the sort of asset side of the pipeline, to the shot side of the pipeline. And we'll talk more about that later, like I said. All right, and for housekeeping in your node graph, you have essentially a material stack and a group stack. You can make nodes like the material stack out of using what's called a group merge. So if I add a group merge in, you'll see it looks very familiar. Simply put, what you have with these items is that it is a node that allows you to create nodes of the same type and just tuck them away. So you'll see that in a short while. It's like I said, it's a housekeeping thing. You got to remember, you live and breathe by the node graph. So a clean node graph equals a scene that is easy to maintain and easy to share. So getting free form and having thousands of nodes everywhere doesn't help anybody, least alone it doesn't help you. So, using these tools that are conveniences that keep everything nice and tidy is a really good way to go about it. Okay, so without further ado, let's start looking at these all in detail. All right, guys, so here we are. Let's take a look at, we'll start with the material and then the material assign, and then we're going to work our way out from that. So first things first, I'm actually going to come in and show you a default material node. So you just type in tab, and it brings up that tab menu, and you can start typing the name of the node. All right, looking at this, we can see it comes out default. So what has happened here is if we look at this with the V key, so that we're viewing and that the scene created by at this node, we can see that this material node, even though it doesn't have any shading information yet, has created a scene graph location named material4, which is designated here. If I change this to my material, you can see the two now sync up, and my scene graph location is there. So the scene graph location, the material type, is a Katana renderer agnostic scene graph location. What each renderer cares about in terms of its plugin is this. I have you assigned an Arnold shader, a 3-light shader, or a V-Ray shader, or a RenderMan shader, or a Redshift shader. That's what it's looking for. Okay, so the material node in the end creates the scene graph location that you can use as the bridge to assign a renderer's shader to geometry, or to volumes, or whatever the entity, the scene graph location that it needs to be assigned to. So that's the interaction level. And here we could create, a standard, a 3-to-light material, and a V-Ray material, and all these are being carried by this my material scene graph location. So if this was assigned to one of these 3 horses, I could literally flip between the different rendering plugins, as long as, again, the other corresponding information that's required by each of them is at that scene graph location as well that I render from. Then you can literally toggle through your renderers and generate images. Why is this useful? You want to render the backdrop with Arnold and you want to render the horses with V-Ray, you got it sorted. If you need to then tag the appropriate surface with the right attributes, it's just fed through and it becomes a sort of legitimate object for that renderer at that time. So it might be that you put all the look development effort into your character with one renderer, you put all the look development effort into the background with another renderer, and you just put a very basic material on so that for the opposite, so that when it goes through, you have something to mat against. Maybe you're sharing the displacement settings and things like that. But all told, it is very possible to run multiple renderers because of things like the material node carrying multiple renders information in an agnostic United Nations of rendering kind of way. Okay, bit of housekeeping. What I want you to know is this. If you take this material node and you copy it real quickly, and just thinking, okay, I'm going to use that as a starting point, and you come here and you look at it, you'll notice that there isn't a second material location. These two are chained together, but I would have thought, okay, well, what's going on here? Why do I not have another one? So what's happening here is you copy and you paste this right now as of 2.5 v5. The name of the node updates, but the material parameter the name parameter of the material doesn't update. So please be aware of this as you're getting started, so that you know that if you do this and you come in and you just add that in, it will then legitimately show the two materials. You know, we will fix that part, but I think it was only fair to point that out so that as you guys get started, that you are aware of it and do not trip over it. Okay, so let's focus here on the fact we've got these three. We've now covered essentially the basics of what you do to create a material. So you've got the material node set in create new material mode. You click on the add shader. You choose the renderer if you have multiple installed, and you choose the type of shader you want to add. You can add multiple if you needed to, so you could add a Arnold displacement shader and an Arnold surface shader, so on and so forth. So you're all good on that front. And then we're going to then use the material assign node. So let's come down here real quick and look at the material assign node. Now in this case, the red shader for the ponies is attached through a drag and drop action. Literally came in, select these, middle mouse button, drag, and you can come up and you drop them in here. Now that's one way. You got to remember cell from our last discussion. You have paths, which is what we're looking at here. You have collections, which is like my selection sets, and you have the ability to drive things by an expression. The two most powerful are definitely the collection and the custom. Because with the custom, you can create an expression that uses metadata or attributes on the geometry and on the scene graph locations to help you assign objects or shaders, or just match to a cell statement. And that has its own power, and it's super, 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 super powerful. The collections just become simplified ways, but because the collections can be created by an expression, you can assign a shader just by a short handle, short name, whatever, however you want to look as an alias. You have the ability to do that. And then of course here you can be explicit, much more interactive in terms of being able to pick one location, shift mouse button, drag it in, so on and so forth. The danger with the paths is that there is not a dynamic link between the explicit path name and the scene graph location. If I change something about the scene graph topology, the names, its layout, the objects, and something gets removed or added, you will not have it jump in automatically. Now, the way around it is doing things like using a higher location in the scene graph. So here we are assigning the gray shader to the background by saying applying it to the world geo. So you could, if you wanted the same shader to be applied across multiple parts of a model that are all underneath one group location, the simple solution is you assign the shader to the group location, not to the actual 20, 30, 40 pieces below it. Where does that get you? It means that if the model changes, then if you add or subtract pieces below that point in the hierarchy, you're safe. So just keep that in mind, that if I now disconnect or disable the red shader assignment, and we do another render, everything's going to come out with the gray shader. So that just, I could add in 10 more ponies and they're all going to come out looking fine. So that is part of the flexibility that you get with Cell and with Katana in general, in terms of the inheritance that you'll hear us talk about a lot that happens with Cell and attributes and the scene graph. Okay, so we've got we've covered that you have the multiple ways to assign. Your relationship is basically you are taking whatever choice you have for how you're telling Katana what to act on. You are then simply assigning the shader. Now, pro tip on this one, this is blue and not the default gray because it has an expression. So you can see what the expression is here. Don't need to actually even type the expression. It's pretty straightforward. Find a material node, shift, middle mouse drag it to the assignment node that you want to use. It will add this automatically. So what's really cool about this is that if I come in and I change the name of this material, it gets picked up here. So expressions in these ways become your guaranteed way to have a dynamic link. Not everything is set up to use that by default. So this becomes just a nice convenience. I'd highly recommend if you, at all possible, while you're going through the look development process, to cover things off this way. Okay, let's loop back and take a look more at the material node. Okay, so we've taken a look at the basics of creating a material via the create new material mode, how you end up with the parameters. We can see which parameters we've changed by the yellow. Everything else is the default. We know that we've got the material locations here. These are what we assign through the assignment nodes. Right, so let's carry on with some of the other modes, because we know that we've got more than just create new material, and it's important to understand the options that are provided to you for these individual modes. All right, so next up, we talked about the idea of expressions and what happens when you shift middle mouse drag a material on top of a material assignment node and how it links the two together by an expression. And we covered how you can use expressions to link parameters together. In a material specific world, you do sometimes have materials that you want to be relatively the same, but you want to start varying small pieces. So you could link everything together by expression. That gets to be a bit over the top, harder to maintain, not as pipeline savvy as it could be. And Katana provides a specialized way of dealing with that. This comes in to a larger discussion of things like making a material library. Katana has built-in functionality for you to create a library of materials that you would want to use on a project. It could be your studio default set that you have, or it could be as refined as the metal, the plastic, the wood, the leather, the concrete, the car paint that you want to have on a project that you have already gone through a certain level of art direction and approval on. You know that they all create the radio Vs. You know that they all work under the same lighting conditions. So they are approved and ready for a broader set of people to use. Katana has the ability to let you distribute those to a team of people, and they can use them as their starting points and start making changes to them in a node graph workflow that's trackable and also has inheritance and will update if you update the library. So without further ado, let's jump in and look at the other ones or the other modes, I should say. And the first one I want to look at, and I'm going to just quickly insert this node here. So we've now, if we look at this one, see it's default, we can see that it's now set to create a material for location. So let's change the name of that and just call it blue material to keep with the naming I have going here. Naming convention, important in Katana. Now, create new material. I could create one from scratch, but I want it to fundamentally be the same. I just want to have a blue horse, not just all red horses. So what I'm going to do is I'm going to say I want to create a child material. So it presents you this option of where does it inherit from. So I'm going to say that I want to take the red material as the parent and create a blue material child. So you can see that there's this relationship now between the red material with the blue material nested underneath it. You can see that I have all the parameters from before. Anything that is gray, we know is not the Arnold standard default. We know it has been changed, and by gray we know that it's changed at the red material level. We can now say that we want to come in, find ourselves our blue, and now let's see here. I know we've got a couple other spots where I have introduced let's see here. Let's just make a lighter blue just for fun. Okay, so we now have a material that is fundamentally, and you can see, like I said, the gray is pointing out to us, or the light gray is pointing out where things have changed upstream. The yellow is telling me what I've overridden, and now the only step left is to assign it. So I can bring in another material assign node, and you can see quickly how if you had lots and lots of materials, that getting into things like a stack node where you can group together your material assigns would help keep your node graph clean. So I'm just going to quickly drag and drop this in. So I've got the path to my blue material. I'm going to pick my middle horse. I'm going to shift middle mouse button, drag him over here. Voila, we've got pony 1 is now going to get this other material. So let's do a quick render of this guy. Okay, so we have our blue horse that is fundamentally the same as the red horses. How fundamental? Well, let's go actually look at how this works. While that's running away, we can come up to the red material, and we can actually come in and say, let's take the glossy specular up a bit. Let's take the roughness way down to make it really bold and obvious. And then we can come over and render again. And there we go. So the blue specific change happens. Everything takes from that is the attributes or parameters that are being described at the red material level apply to all of them. And this nesting, it can go even deeper. So let's take one step farther, and we will make another material node. And we'll just sandwich this one in here, do a bit of housekeeping, move these up a bit. Pardon me, there we go. All right, so we've got this one, which we will set to be a new child material. We're going to take the blue material, in fact, and we will spawn another one. We will call this one green material, and let's do the same. So let's make a nice green, but let's leave the subsurface as blue for now. Let's make a little bit more room here. Expand that. And let's drop in another material assignment node. Right there. Let's now take the horse on the right hand side, add him in, and if we open this up, we can see we have green material below that, and away we go. Okay, So you can see you can create a hierarchical set of shaders that can then be used and inherit my changes. So if I wanted to, I could change something specific to the blue shader that would then be picked up from the green shader and so on and so forth. So it's again one of these things where it's super powerful, but think your way through how you use it. You don't want to tie yourself into knots, and you want to sort of use as much flexibility as makes the most common sense. Okay, so what I've done now is I've rejigged things a bit from our example where we're creating child materials and actually converted these just to be new materials. Because I wanted to touch on this idea of creating a library of shaders or materials so that we could make use of the next part. So we have a mechanism in Katana called a look file. It's used for essentially capturing the difference between 2 points in a node graph and writing out those instructions. But there is a use of it where you can actually use it to create a shader library. That library, like I said before, could be just a basic starting point. It could be a more refined and art-directed approved set of materials. Nonetheless, the mechanism that Katana has built in for you to use that and not have to build it yourself is pretty straightforward. So here I've got the tail end of where all those materials are, so I don't need to wait much longer or do this anywhere else. I've got this look file material out node. What I can do here is I can come in and I can say that I want to find a location. So we will set it to my desktop, and we're going to say that we want to make a library called Jordan's Materials. So what's going to happen is that the materials in my project are going to be written out to a data file. Okay, so I'm going to accept that, and there we go. It is written out to disk. If we were to look at my desktop, we would find this file. So what does that mean? Well, it means that I can now bring in an independent node. This could have been a different scene. And I can say that I want to find that. And there we go, my materials. And if we look, you can see it gets brought right back in. So that's pretty cool. I mean, it's built-in transport of your materials from one file to the next, and you can centralize that. You have the option to read it as a reference or not. In other words, do you want a live connection that updates as quickly as flushing your caches, which is this button here? Or do you want it to be a little bit more of a pull mechanism in terms of a artist requiring that they want to go find new updates rather than the updates are pushed to them? And you could still have the push mechanism if you just use versioning and things like that. All right, one other part that you can make use here is you can actually decide where you want to put these as well. So I could say that I want to go at root materials library, and there you go. They are all going to come underneath this location. So you could create your own location that you wanted these to be shared from. And that way, if you wanted to, you can basically group them as needed, and away we go. All right, so let's look at the other nodes that could then be used if you either have materials in your own scene already, either by your own construction or if you had brought them in from one of these look file material in nodes. Okay, so I've come back to our red porcelain pony setup, And let's take a look at the next two major modes of the material node. All right. So we have the create material we've talked about, child material we just went through. Let's talk about the edit material. Now I add this in, and you can see that one of the first things it asks is for location, and it tells me it's going to display parameters. So let's add that in. Alrighty. So the material for node isn't adding anything here because it's going to fundamentally change one of the shaders. So let's say that I want to give it the red shader. Now adding that material location loads all the available parameters for that material. Now because I've created this from a stock Arnold standard shader, I've got the full kit right there in front of me. So I can come in and you can see the grayed out or the dim yellow, which is telling me what's changed from the default. Now I could come in and say I want to drop the KD. And get a darker result. I could change the color. Okay, so what this node is doing is that the material node in the edit material mode is taking all the available parameters from the material, presenting them for you to edit, and it's going to be global, indiscriminate in how those changes are made, because it's just brute force changing that one material. The next mode that I want to talk about gets a lot more precise and is a lot more powerful. Okay, so let's actually chain together these. So we've now overridden our red and we've made it yellow. So we make a red material here. We change our mind there. If I disable this, then there we go, back to red. Why would you want to work this way? Think of it when you're working with the art director. They may want to see a few different options. You don't fundamentally want to have to go back and start from scratch. You want to make changes. So why not come in, make multiple sets of these nodes, and you could toggle through various options. You could use a graph state variable on switch node to set up a whole little customizable rig that you could just toggle through. You could do all kinds of sort of exploratory work without basically destroying sort of a good sort of midpoint that you were at. So that's, one of the ways that this works. Okay, so we're going to make our things yellow again. Let's add in a new material node. And let's make sure it's connected in. Right. So you can see by default popped in 5 or material 5. Let's change it to override materials. Now this is where things get pretty cool. So we've got a material that's assigned to all the ponies. We want to be precise about a change in how this is used or edited. So what I can actually do is I can find that I have the red material. So let's say that we want to change the color. I've got the red material selected in the scene graph. I go to the attributes. I can find my way down to the parameters. I can go to the diffuse. Here's the color. So we know that we went from red. The next node changes it to the yellow. We can see that yellow here. I can middle mouse button drag the attribute of color to here. Now I can say that I want to make it blue. Now the next choice is, where do I want to make those changes? So if I come in, I could say I want all the ponies, and I can render. And I get my purple because they all had the red subsurface, but it's happened to everything. What's cool though is you could be laser focused, because I could have said pony star with an expression, and then every pony in the whole scene would have got it. But let's take it down to just pony 2. So what's happening is pony 2 is being told, okay, once you get to your material, what I want it to happen before anything else goes on is I want you to override that attribute, the KD color, for that one specific model is going to then get the change. I could add in another material node. I can say that I want to change the mode to override. I could pick something like the gray material. Again, go to the attributes. I can pick the color. And now I can actually even target at geo level. And let's just change it to, let's go tone on tone and make a nice warm color. Right, so if I had had multiple gray objects within the scene, by assigning where I want that material override to happen at a higher level than everything that would have received that material will now get that override. So it's pretty powerful, the override mode, and how you can be laser focused or completely broad. You can be down to one attribute at a time. You could do a full set of attributes if you want to, but it's all trackable. This is what's so cool about the node graph, is that everything you do, it's like a breadcrumb trail. So if somebody wants to know what's happening, well, they can sit here and just go disable this, do a render here, and we'll be back to our gray. So you can completely debug what's going on. And by working with multiple nodes, instead of just kind of going and changing again and again attributes on various things, you can still, at the end of the day, when you're done with it, if you wanted to just clean it up, you can sort of shuffle all those changes to the parameters that you're making into just the base material definition. But while you're working, you've got the multiple nodes that sort of give you your step-by-step breadcrumb trail. You can branch and things like that. So it comes in quite handy. Now, let's take a look at that one last mode. Okay, so I've reset everything back to our red porcelain ponies. And let's take a look at what comes up next. So coming back to our materials, if I bring in a material node, and we come in and say that we want to create from look file, what happens? So we get presented with the option to find a look file. We know that we put one on my desktop, so let's go find my materials. I can choose which of these materials I then want to use. So let's try the green, and then I get all the green ones. And again, color coding showing where things are being changed versus the default. Very clear again. So I've created this one, but it doesn't mean I can have to live with it the way it is. So let's make this a orange material. I can come in and change that. So that is the only thing I want to change. This could be in a metal, this could be in some other setup. And it's really just straightforward to say that I want to make those basic changes. And let's just do this the clean way. Shift, middle mouse button, drag. That way we know that we get the expression driving what's there. Let's take our right hand pony, shift middle mouse button, drag it up here. Okay, so if I now do a render of this one, not the prettiest orange, but there we go. And if you remember, the green shader when we exported it had different specular properties and look to the rest. So again, you could have this as wood, metal, car paint, just even like a basic starting point for how you want your materials to look. You can then save those out, bring them back in, and that's how you would, the second way that you can create a material from a library file. Okay, well, let's take a break from this and move on. All right, guys, so let's take the next step. We've gone through everything about materials, how you create them, how you edit them, some pipeline savvy ways you can use Katana to create shader libraries and how you could import those, how you can link together shaders by using the child material mechanism. Next up on our list will be how do you make networks of shading nodes. Same thing as you would do in, say, something like the Maya Hypershade. And how does that work? And what are the particular ways of working for this inside of Katana? So what we would do is first we have to cover how do you get started. So a material node creates a material location, and then you attach inside the material the shader you want. So network materials are similar in that they too create a scene graph location. Notice though that there are no node graph connections at the top. So first thing I need to do if I'm going to use this live in a node graph is I'm going to make a merge node, and I'm going to connect that in, and I'm going to pipe the network material into the merge node. And you can see now I end up with the network material 1, which is coming from here where I create the name. So I'm just going to customize the name. All right, so we have my network material. Right, nothing. It's a free floating node that has no ports. Well, that's because you need to add the terminals. So presented after you click on the terminal button is all the types of terminals that shading or that network material node can create for you for that rendering plugin. So Arnold, I can plug in a surface, I can plug in displacement, I can plug in the bump, and now I'm ready to actually connect things to those. So I'm only going to use the surface in this case because you guys know all about using Arnold or RenderMan. You just got to know that this is like your Maya shading group. So this is the thing you connect all those shaders to then be able to connect the material or the shader to the geometry. So what you can do then, here I'm going to show you the slow way, and then I'm going to show you the optimized way, and then we'll continue on with the optimized way. So bare bones, what you do is you type in tab, and you would say for Arnold, if I could type, you would say Arnold, and then you would find the shading node. All right, so bare bones. Now what we have here is, if we look at it, we have the type, the name of the node, and then the type of function it can provide. So everything you would have available for Arnold in M2A, H2A, and whatnot, all those nodes are here. You just have to choose which one you want. So this is a generalized mechanism by which we allow the renderer vendors to package up all their shading nodes so that you don't end up with 1,001 shading nodes free floating in your menus. I'll show you how to make this a lot easier to work with them. All right, so we want to add in a standard shader. So here we go. This shading node is now functioning. We're going to call the Arnold standard shader, but we should probably say that we want to call this our AI standard. Again, seem to be challenged on the typing front. All right. So we now have a node called AI standard. It is a shading node that we need to then say we want to connect to the surface port. So well, there we go. We now have, at the very least, a default set of parameters for the Arnold standard shader being fed to the network material, which is then available in the scene graph to be connected to geometry by the material assign. Pretty straightforward, but you could do this with a material node. So where things get more interesting is when you have access to all those shading controls or shading nodes and you don't have to go through all those steps. Word of warning, each of the shading nodes in the scene has to be uniquely named. Otherwise, you run into conflicts, so it's not just localized to what's connected to this. You do have to have some degree of keeping things unique in their names. Otherwise, you will error out and things will turn red. So what's your best way around that? Well, we have something called the tab menu API, and I will put into the forums the little script that I'm running. Simply put, I've got it set up so that when I hit S, it gives me a list. It's querying that node, pulls all the list of possible options. So when I say I want a checkerboard, I get that. And what it's going to do is it's actually made a Arnold shading node, named it to checkerboard, so it's uniquely named. And then it is going to allow me to, if I pick the right output, connect it to the color. All right, so there we go. So I now have a checkerboard connected to the color of the Arnold standard shader, and it's set to be assignable. So let's do that. All right, I'm just going to add a material assign node real quick here. Just going to go full screen to make dragging and dropping easier. Same things apply. And now I can very quickly say that what I want to do is let's go with the middle pony. Okay, so I'm specifically assigning the middle pony the Arnold standard shader as it was created, and we can see that it's being linked by the expression. So if I change the name of this node, it all carries forward. And remember, shift middle mouse drag a material or network material node to a material assign node automatically makes this expression. Okay. So what does this look like? Right. So there we have our checkerboard scattered across the pony. So next step, I want another checkerboard, and you can see it's now named it checkerboard 1 on the name of the node, so we're all good. I can take its output, bring it to the input, say that I want to map to color 1, which I know is going to be the white. So, and here I can then also say the frequency, let's do 4 by 4, and let's change the color to be yellow and purple. Why not? More of a pink, but hey. Right. So let's preview render that. Okay. So we have created a network of shading nodes. So I'm not going to go on and make a complex one because you're not here to watch me do look development that you guys already know how to do. You just want to know how do you do what you already know how to do, just in Katana. So this is how you go about creating a shading network and how you get it connected. So you can start to see that there's things that are common, things that are slightly vary between packages. Now we can get on to this extra layer I was kind of alluding to before. So you know that you can write out a material to a library. You know that you can reuse materials as children of another material. Um, and you know that sometimes things are going to get complex. So what happens when you want to actually make something more simplified? You want a car paint shader and you want to only be able to give your artist control over the actual color and not necessarily change the rest of the properties. So you can do this and it's fairly straightforward. It does have a few tricks to it, so we'll cover those and then we'll see how this works. So the best mechanism for previewing what I want to show you is that we will create a child material, right? So let's do this. So let's bring in a material node and let us look at connect it up here. And we are going to say make a child material. And what we want to do is we are going to call this one network child. We are going to say that it's going to inherit from the network material. Okay, so if we were to view this 3D scene as it came out here, we now have network child and network, right? Okay. Now, what happens with the parameters? They're empty. Why are they empty? So one of the benefits of the network material is that when you cascade it forward, shall we say, in a setup or a pipeline, you have control over what you expose and how you expose it. So what I can actually do is say I want to come look at the standard shader. I can see that I've got a color that's connected to the checkerboard output, but I do have the diffuse amount. So let's start basic. On the little wrench symbol, click on Edit Parameters or Edit Parameter Name in Material Interface. You get presented with this option. I am going to call this df amount, and I'm going to put this in a group called diffuse. Now I get told that the KD appears as df amount in group diffuse. All right, so if I look at the network material, you'll see that I actually have now started adding things to its surface layer. So think again, the network material is like a gizmo from Nuke or a macro from Katana. You have the ability to start promoting up controls. Now, if I come down to this material node, where I am now starting to make parameters appear, you can see this is what an artist, if they had inherited this material from a library or another asset, this is what they're going to get presented with. So it's pretty cool. So I can now say, okay, well, in diffuse, I want to come back up to my checkerboard, and I know that the control, so I want the U and V frequency. So I can say that I want to come across and do this. So I want, let's see, remember, I need to have some uniqueness to this, and I'll show you why this will error out. So let's just do this. We call it frequency. And we're going to put this in a group called repeat. Okay, so far so good. Come down here, I get repeat, and I get frequency 1. So, right, what happens now if I come in and I say that I want to do this one, and I want to have the name frequency in the group repeat. You'll see things error out. So it doesn't know how to resolve the name conflicts. All right, so it's really important when you are working your way through this that you give everything unique names. So, I mean, this was a pretty straightforward example. I mean, I wouldn't have expected that to work in most cases. So we've got now unique names. I get my U frequency, my V frequency. But what happens if I were to go to the second checkerboard and do the same thing? So if I came to here and said that I wanted to have name U underscore frequency in the group repeat, even though they come from separate nodes, again, it's going to conflict, right? So you just got to be careful and strategic in how you name your nodes. So we can say repeat 2. You can make more meaningful names than that. But nonetheless, you should be able to work your way through it. Now, notice it is still erroring out. So even though I'm putting it to a different group, this U frequency is still a problem. So the degree to which you have to create unique names is just something to be aware of. And there we go. So it's not ideal, but it is how Katana works currently. And I'd rather that you know about it. So there you go. But what's the real power to all this? Sort of gotchas aside, the real cool thing, though, is that I've now been able to create a material that I have a limited set of controls for that I can use to actually propagate through a series of from assets. And if I go back to this network material and make a change, then that will carry forward through the network as well. So that's the basics on network materials, and then material assignment. Next, we'll look at image maps and UVs. All right, so look development wouldn't go very far without file textures these days. So the question then becomes, how do you deal with file textures inside of Katana? And what are the more Katana-esque options for how you deal with it? And then also, with file textures comes either projections or UVs. So let's talk about some of that. So first off, what we have in front of us is the name for the shading node from each respective renderer plugin and its ability to bring in file textures. So starting with 3Light on the left, they have the file node. Arnold calls it image, Redshift texture sampler, Renderman has multiple, but the basic one is the PXR texture, and V-Ray, the V-Ray bitmap. Now, one thing to keep in mind is how do each of these then deal with UDIM textures? Well, for the most part, they're pretty good and leave you a little breadcrumb trail. So if we come take a look at, say, the Arnold, we have a little help pop up, and it's going to give you the description of how you need to structure your names in terms of UDIM, and also they've left you a little breadcrumb trail over how to use the user data parameters, and we've got an example file coming up which will show this in more detail. Okay, so onwards, you look at RenderMan, slightly different description. So depending on which render plugin you're using, just take a look and see. Like I said, they've been really good about actually outlining the syntax you need to use for getting the various aspects of UDIM and whatnot in here. And this really sort of just makes it fairly straightforward. All right, so let's take a look at the next step up for things and sort of combine this with, if we then said, let's say like with the Arnold, let's quickly set ourselves to be Arnold related, and let's make a standard shading node quickly below this one, and then below it a network material, because I want to sort of recap quickly on what we talked about before when it comes to how all these can come together. All right, so let's make sure we've got the Arnold surface shader port terminal there. All right, so we've got our network material that's linked through all this. We can come back to the material. So if you wanted to create a Uber material, because shading typically falls into one of two camps. You're either going to be all network all the time and you want it exposed and everything's kind of, sort of out there in terms of the shading nodes. And then there's also the Uber shader model, where it's the idea is like everything's compartmentalized into that one entity. So whether you've got fractals, things like that, you can create a starting point that has a lot of utility functions to it already, but it's pipelined very tightly and controlled so that you know that there isn't going to be any variance between artists. So how would you then get a file texture and promote it up so that an artist could change the texture map involved? And it's pretty much exactly what we talked about before. So we go to the file texture, in this case, the image with Arnold. We can choose that we want to have, say, diffuse under TX as the name, and let's put it into a group called diffuse. And there we go. So we know that that is being presented up. And let's just call it my texture dot tx, let's say. All right, so we know that we're going to have a parameter group called diffuse, and it's going to have diffuse tx. And then if I come in and put a material node here below this one, just like we did before, and we say that we want to create a child material, and we are going to choose the network material, and we're going to make material. We then have access to that file parameter. So it's just that simple. If you want to work with file textures and you want to then wrap them up and expose those, that's just the simple, straightforward way of getting them out there. And again, remember, each of the render vendors will supply the syntax for what they're expecting in terms of UDIM support. And it's up to you to sort of go about making your TX files or what have you that you need for each particular vendor so that they have the proper mipmap support texture. Okay, so we've looked at materials, network materials, images. Now, along with images come UVs. So here we have our Moto Ace character, part of the auto characters set up by Lukash Becerra, modeled by John Hayes, all available on the community share site from our website. So what we want to take a look at is, how do you actually interact with UVs? What can you actually do inside of Katana? So UV Viewer tab, fairly straightforward. Where do you get to with it? Well, select your model that you want to view the UVs for. It displays it. You have options for UDIM and Mudbox style display of UDIM or UV locations. If you have an advanced pipeline where you're tagging your geometries with the texture maps they need, they will show here. If not, fear not. Loading the texture maps is pretty straightforward. You can come in and find the texture map that you would like to use. And let's see, for this one, let's look at this one here. Perfect. So there we go. We have our UVs and the texture map for the character. So fairly straightforward. But you do have to keep in mind that the purpose of this view is for troubleshooting. You get a bit of a stretched UV on one of your renders. You want to know, is that the right set of UVs? Is that working appropriately with the texture maps? You can come here and take a look at it. Katana is not set up to edit UVs. So if you do have a problem with the UV, then the next step is to go back to the source, fix it, and bring it forward. Okay, so UV is out of the way. The next thing that comes up is polygonal face assignments. People ask all the time, okay, well, the way that my models are constructed, I need to be able to assign shaders to a portion of one polygonal cage. Not, I don't want to cut up my model. Fine, that's, sort of very standard practice for everybody. So the way you do it is face sets. The most logical way to make the face sets is in your other 3D application. So here are the face sets. They just show up as scene graph locations. But exporting them from the model time is pretty straightforward. Maya, you just go about making your polygonal face assignments, and you make sure that you have this little doodad turned on your Alembic export. So as long as you write out your face sets, then you are all good to go. And those will come through. They'll be named by the shading group name, and you are all set. If you are coming from Modo, on the other hand, anything that you assign as a material to faces will come out with the tag or the shader name. So you're fine there, or the material name, I should say. So that's how Ace here was set up. So the fact that he's got a body, a face, leather, soles, and vials, and you can see that all the different pieces highlight. So just using material assign nodes, we can get all these covered up with different pieces. So we can take a look at that in just a minute. So here we are. It is the, we are using the RenderMan plugin, and you can have access to that. It's the RFK. Just ask the RenderMan team. So something a little bit different about this, just to help with this demonstration. So I've used a material stack this time, so you can see it has no input. So it's a group merge type node. And then over here, we have a material assign stack. So in a case where I'm going to have lots and lots of materials, I can keep my setup a lot cleaner by just using a couple of stacks, and therefore I don't need to have a whole lot together to get everything working. So first things first, let's just add a few materials. So right now I've got a gray material that I've just thrown across everything. So in this material stack, which is what we call a super tool, and we'll explain more about those in the futures, I can say I want to add a child material, and it is going to take the one I've already selected, make the child of it, and then I can just simply give it a name. So I can say body, and then I can come up here and I can say that I want to add face. let's say we want to add boots. Oh, spoke too soon. Child material. Boots. And finally, let's make one for the vials. And just real quick, let's just change the colors on these. So okay, so we've gone through, we've been able to create a whole bunch of materials really quickly. We can come down to here. Now we've got one material sign that's going to geometry only. I did one in quickly that was going to one of the other face sets. So let's just get rid of this one assignment. And we'll add in, so we'll just do name here. So MA for material assigned gray, just keep the naming convention easy on the eyes. So we'll say MA body, and we'll just do boots. And let's do face. We don't need to do all of them. All right, so the catch using the material assign stack with the material stack is you really don't, it doesn't respond well with the drag and drop. So we're just going to do it the old fashioned way. So I'm going to take the body and put it to the body. Boots, we will put with leather, because they're all going to be that. Face, we will put with face. Materials are all up here, so then we're going to go through again real quick. Body material, boots material, face material. Oh, and the reason why I am getting the wrong color off of face was I put drag and drop the wrong shader. Boots for boots, face for face, body for body. Let's try that one more time. Okay, so there you go. That is the basics of UVs, or at least inspecting UVs and using face sets for polygonal assignments. And next, we'll take a look at actually creating face sets inside of Katana. Okay, so looking back at our race character, what happens when you don't have a face set exported from your 3D package and you need to create a new one? Can you create them in Katana? Absolutely. Katana is geared as a lighting and look development tool, so it does not have the robustness of, say, a modeling package, which is why I recommend using Maya and Modo as much as possible. It's an area that will improve in the future. But for now, if you do need to make one inside of Katana, then let's show you how. Okay, like everything in Katana, the answer is there's a node for it. Just like they say for iOS, there's an app for it, and Katana, there's a node for it. So if you want to create a face set, come in and drop that in. Now, so it's connected in, you can name the face set. Just using that as a naming convention. Now, I'm just going to isolate it to that piece of geometry. That's fine, so it knows where to pick from. So there's two more steps. So next easiest thing to do. Shift middle mouse button, drag the face set create node to this icon on the viewer. Okay, that puts you into polygonal selection mode. Now you can see I'm having trouble getting close enough based on the scale of this model, and I wanted to show you this. So, clipping planes for the viewer. Go to project settings, viewer settings, expand it out till you get to the perspective camera, if that's what you're looking at. And there you go. No problem anymore. So, what you do is you have to select the faces that you want. Right now it's set up such that you have to get the little point in the middle of the quad. You pick the faces that you want. The usual shift selects and control select workflows apply. So let's say we wanted to have this here as our face set. Now I've selected the polygons. I've got the object drawn in or highlighted. You just say adopt faces from viewer, and there you go. That face set is now created for that location. And if we unfold the triangle, we will see material something showing up there. So I can now assign a different material to that location. Okay, so we have here a file loaded that is going to help us look at something a little bit more TD focused. How do you build up a pipeline where maybe you can start getting a little bit of automation of your texture map handling for your materials? So already we've looked at, you've got a great possibility for things like look file based materials and making child materials. And this starts to sort of take that level of automation down to the texture map level. So we've got a small scene. You can find it here under the example projects, texture resolving. I've opened up, in this case, the RenderMan 21 version. And I am looking at the top left quarter of this image, or of the node graph rather, and we're going to deconstruct how this image came about. So the guys have left some nice notes here, but let's take a look at what's actually going on in the scene. So we have a shading node subnet, which is basically a group node for shading nodes. We have a PXR texture and a shader plugged into a network material, but the magic starts here with the PXR texture. So this expression here, the adder:textures.callMap, is what is telling Katana and therefore RenderMan, look for this attribute, and that is going to tell you what is going to go here. Because what's actually happening is when we come out of this group and we get down to the assignment, you can see that the actual same texture is being applied against everything. So we get down to this house scene, and then everything below it that is a type polymesh is going to have this assigned to it. So it's going to be making individual assignments to those models, and that is the part where things start to get interesting. So let's actually take a look at some of the pieces of this model. So if we look at the roof here, and what we see is that we have under the geometry section of the attributes, we have an arbitrary, which is where all the extra ones come in from other programs. We have mat tag of type primitive, or scope primitive, I should say, and the value is roof. Okay, so we know that that is the material that's going to be applied, but somehow that has to be translated into a path to a texture map. So how does that happen? Okay, that's where op scripts start to come in. So in this one here, what we have is a simple little op script that's saying that it wants to find the user.txt directory, which is defined at a different point. We have the geometry.arbitrary mat tag value, and then it is simply combining those together to declare this adder of textures.callmap. Okay, so where is all this coming together? So if we look at the, we see that we're operating across the whole scene. We have the user parameter here that defines my root directory. So together, so it's what it's doing is it's saying the users.txt directory. So users.type or that group, the txt directory, is joining that together with the attribute of that mat tag. And from there, it's going to create a parameter that when we look one step below, we should now have this textures dot call map. So we have the fully executed path that shows that is now referenced by the shader. Okay, this happens across all of them. So if we pick the ground, we'll see that each piece has a fully built out path to a texture map, which is then fed to that shader. So everything you see here is still using the one shader or the one material, but it's just modulating its results based on the fact that it can be feeding it a different texture based on the arbitrary data. So how do you get this data in? There's multiple ways. It could be written out as part of the alembic on the way out of Maya. It could be referenced in the case of this example that you'll see to the left, that you have an attribute file that is loading and applying those bits of data. So what's the benefit of using an external file versus the alembic? Well, the answer is if something changes, you don't have to re-export your alembic to change the reference to a texture map or other data. So that, it comes and goes based on what do you want to achieve with your pipeline, but keeping an external file reference for the metadata does come in handy. So I will let you guys play with that and explore it. Come back to our forums, ask questions. There are many examples in this one file that just show you the different possibilities. So go ahead and check this one out. Okay, so I think we're at about an hour and a half. I'm going to, sort of move us over to the question and answer time. What we'll do is we'll move discussions of look files in terms of how you transport this look development work once you've made all these network materials and got your texture maps all hooked up. How that moves into the actual shot side of the pipeline, we'll talk about next week. We'll include that with all the discussion about the gaffer, differences in live rendering versus preview rendering. I've been mainly using the preview render mode as opposed to the live render mode, as that is the thing that is the most consistent across the render plugins. When you get into live rendering, the functionality or depth of what can be changed during a live render session changes a bit, so we'll cover that next week. And yeah, I am looking forward to your questions. And if you guys don't want to ask questions now, please feel free. Come out to the forums, ask those questions there. We'll upload these files to the learning forum post, and you can just jump in. So thanks again for your time. I appreciate the fact that all of you have taken an hour to hour and a half of your own day to either watch this or to join us live.